Anyway, so I'm going to talk about photosystem 1 and 2 and the Calvin cycle. So starting off with the Calvin cycle starts with 3 molecules of CO2. That's made into 6 molecules of 3-phosphoglycerate and ATP. Oh, sorry. ATP is converted into ADP. That then makes 1,3,5-phosphoglycerate, and then NADPH is made into NAD plus, and a phosphate comes out. That's then made into glyceraldehyde 3-phosphate, and glyceraldehyde 3-phosphate can be made to 1 molecule of glyceraldehyde 3-phosphate, which makes the sugars fatty acids. And I believe like one of the things it had on the document was glucose, and so sugars, fatty acids that can be sugars could be glucose. So that's what I'm assuming that is. Anyways, moving on to that can go there or it can still complete the circle into 5 molecules of glyceraldehyde 3-phosphate. And 2 phosphates come off. That then makes ribulose 5-phosphate 3 molecules. And that then goes and completes the cycle. And ATP is converted and made to ADP like the last time. And the last molecule made was 3 molecules of ribulose 1,5-biphosphate. And then it just goes into the complete circle again. So moving on to photosystem 2 and 1. So I started with electrons, because electrons are going to come from the electron transport chain. That's going to be throughout this whole system. So it starts with light, and it's going to come into the antenna complex, and H2O water is going to be converted to O2, and 4 hydrogens come off. This will be like a water splitting enzyme. Anyways, moving on. So the electrons are going to continue on through here, and it's going to hit the plastoquinone, which is basically it keeps the electrons mobile, so it keeps moving them. That then is going to hit the cytochrome B6 complex, where the protein. This is like this makes the protein gradient. So H should come in and it comes out. This keeps the system active and to keep going. So the electrons then continue on to the plastocyanide, and from there this starts the we're now into photosystem 2. And so light again comes and hits the plastocyanide, and that then hits the peroxide G side or whatever. And H comes in, obviously, because from the proton gradient, and it converts NAPH into, it converts NAD into NADPH. And this peroxide complex continues on, and ADPH is converted to ATP. And basically what I found similar between the two was that, well, it's not similar, but it kind of is. In the Calvin cycle, it was NADPH is converted and made to NAD plus, and here's the opposite. But they're both needed throughout the cycle. And also ATP, which is energy, is used in both of the cycles. So it's NADPH. So I found that interesting because they're both used in both of them. But that makes sense because you need energy to promote both the cycles from working. So that's what I found interesting. Thank you.